Okay, now we see about a total different topic. So that is radial probability distribution curves. It also belongs to orbitals. Okay, so in the radial probability distribution curves, so now we see the definition. So what is mean by? So what is the actual meaning of radial probability distribution curves means? The curves means these are the graphs, nothing but the curves obtained by plotting a graph between, here it is important, that is a radial probability, between radial probability, that is capital D, and distance r, small r. From the nucleus. See, so radial probability distribution curves means, so these are the curves obtained by plotting a graph between radial probability. So here important the new word, that is a radial probability, and the distance r from the nucleus. Okay, so from the nucleus for an electron or for an orbital, for an orbital. Orbitals are the electron present in it. Orbital or the electron present in it are called radial probability distribution curves. So here we know about the distance from the nucleus, that is small r. Then we need here the new word is, new concept is radial probability D. So what is mean by radial probability D? Now we see about that. So now we see about radial probability. Okay. Just wait. So there is radial probability, that is called capital D. Radial probability, that is capital D. So radial probability means actually what is the value of that D is 4 pi r square dr into psi square. So we know about the psi, it is a wave function which indicates about the wave nature of electrons. Okay, so the capital D is equal 4 pi r square dr psi square. Here we know what about the psi square. The psi square is always indicates about the probability of it tells about the probability of finding the electron. Means where the psi square is maximum, that is the probability of finding the electron is maximum at that place. If psi square is equal to 0, At that place there is no probability of finding the electron. Next here, what about dr pi 4 pi r square? So this 4 pi r square dr indicates, this combined value indicates that the area, nothing but for example, if we take a circle, so this is from nucleus, so the electron moving in this path, so this is the electron moving path. Okay, this is circular orbit. So how much distance is present for this r? So what is the area of this? What is the small distance? That is dr. Okay, so now the 4 pi square dr. So here for example, if you want to get this small area, okay, in two circles, this is the inside small circle, it is a big circle. Okay, the inside small circle, big circle, two circles between the area present between the small circle and big circle. How we calculate? So at first we calculate the volume of the inner sphere, nothing but volume of the small circle, nothing but it is a sphere generally. Okay, means here the area or nothing but this weight. Okay, so now here we want to know about the volume of this shell. Okay, so ఈ ఆర్బిట్ ఎలక్ట్రాన్ మూవ్ అవుతున్న ఈ ఆర్బిట్ వాల్యూమ్ ఫైండ్ అవుట్ చేయాలి. Means we want to know the volume of the inner space between the two spheres. Okay, so how we can write? So we are writing the formula here. 4 pi r square dr means so what is 4 pi r square dr? The dr is the this distance, and here see we can write a direct relation, that is a volume of the shell. So what is volume of the shell? So ఈ shell ఈ area, so ఈ area shell volume ఎంత అవుతుంది మనకి? The higher value minus inner sphere, means we can write the volume of big sphere, the volume of larger sphere minus volume of this smaller sphere. Okay, so then we will get the area of this inner part. So inner part lo unna area find out cheyalante, so inner part higher part minus inner part cheseste we will get this area. Okay, so inside local orbit area we are able to get so what is this radius? Inner sphere radius is r. So outer sphere radius becomes how much? Outer sphere radius becomes r plus dr. Now what is the volume of the larger sphere? Means what is the volume of this larger sphere? 4 by 3 pi r cube. Radius is how much here? Dr cube. Minus what is the volume of the inner sphere? So inner sphere volume is how much? Again 4 by 3 pi r. Its radius is r is given, pi r cube. So by doing these calculations, the mathematical calculation, that is a plus b whole cube. Okay, so by doing all this calculation, here we will get 4 by 3 pi r square dr. 4 by 3 pi r square dr, and total calculation we will get that. Means what is the 4 by 3 pi r dr? Means this is volume of the shell. This volume of the shell having distance dr. Okay, so now we need to find out ఇప్పుడు న్యూక్లియస్ నుంచి స్మాలర్ డిస్టెన్స్ లో ఉన్న ఈ డిఆర్ లెంత్ సైజ్ లో ఈ డిఆర్ లెంత్ సైజ్ కి వాల్యూమ్ ఎంత 4/3 పై స్క్వేర్ డిఆర్. సో ఇప్పుడు ఈ ఏరియాలో మనం ఫైండ్ అవుట్ చేయాల్సింది ఏంటిది? probability of finding the electron. So probability of the finding electron means psi square. So therefore now we can write, therefore the probability of finding the electron in the shell which is having volume 4/3 pi r cube, which is having volume 4/3 pi r square dr is equal to 4/3 pi r square dr into psi square. Means 4/3 pi r square dr plus adinti manaki only the volume of the shell. Volume of the shell matram 4/3 pi r square dr. Okay, just now we calculated by taking the inner, by subtracting the outer sphere volume minus inner sphere volume. So outer sphere volume my inner sphere value minus చేస్తే we will get the orbit, nothing but ఆ షెల్ వాల్యూమ్ వచ్చింది మనకి. ఇప్పుడు ఆ షెల్ వాల్యూమ్లో ఫైండ్ అవుట్ చేయాల్సింది ఏంటిది? ప్రాబబిలిటీ ఆఫ్ ఫైండింగ్ ది ఎలక్ట్రాన్ ఇన్ ఇట్. సో కాబట్టి ప్రాబబిలిటీ ఆఫ్ ద ఫైండింగ్ ఎలక్ట్రాన్ ఎలా వస్తుంది మనకి? psi స్క్వేర్తో. సో ఈ స్మాల్ ఏరియాలో వాట్ ఈస్ ద ప్రాబబిలిటీ ఆఫ్ ఫైండింగ్ ది ఎలక్ట్రాన్ మీన్స్ 4/3 pi r square dr into psi square. So this is known as radial probability capital D, which indicates about the probability of finding the electron in the small region 4/3 pi r square dr, which is distanced from, which is having distance smaller from the nucleus. అంటే న్యూక్లియస్ నుంచి స్మాలర్ డిస్టెన్స్ లో ఉన్న స్మాల్ రీజియన్ డిఆర్లో ఎలక్ట్రాన్ ప్రాబబిలిటీని ఫైండ్ అవుట్ చేసే ఫంక్షన్ radial probability function, or it's called radial probability capital D, 4/3 pi r square dr into psi square. Okay, so దీన్ని మనం గ్రాఫ్ లో ఎక్కడ చేస్తాం? దీన్ని r తో కంపేర్ చేస్తాం. So now we see some plots, some radial probability curves. Okay, just listen 2-3 times to understand it. So radial probability curves for 1s orbital. So on the y-axis capital D, on the x-axis take distance, that is the distance from the nucleus. Okay, here for 1s orbital at 0 level there is no electrons, means distance 0, the nucleus నుంచి 0 distance అంటే nucleus న్యూక్లియస్లో నో ఎలక్ట్రాన్స్, కాబట్టి అక్కడ ఫైండింగ్ ది ఎలక్ట్రాన్ ప్రాబబిలిటీ 0. సో 1s ఎలా ఉంటుంది? ద గ్రాఫ్ ఈజ్ లైక్ దిస్. సో ఒక ప్లేస్లో మ్యాక్సిమం అవుతుంది. ఓకే, దిస్ మ్యాక్సిమం రీజియన్. సో దిస్ ఈజ్ ఫర్ 1s and take the for 2s. So for 2s always D on y-axis, radius on x-axis, at 0 position means 0 distance from the nucleus, means in nucleus there is no electron, that's why ఇక్కడ height 0 నే. సో 2s మనకి ఆర్బిటల్ సపరేట్ గా మనం డ్రా చేయాలి. s సబ్ షెల్ సపరేట్, p సబ్ షెల్ సపరేట్, d సబ్ షెల్ సపరేట్ గా డ్రా చేస్తాం. ఇప్పుడు s డిస్కస్ చేసినప్పుడు there is no discussion about the p orbitals. ఇప్పుడు 2s రావాలంటే ఫస్ట్ ఏం కంప్లీట్ అవ్వాలి? 1s కంప్లీట్ అవ్వాలి. దిస్ ఈజ్ 1s and this is 2s. Okay, So at first 0, and this indicates the highest indicates the maximum probability. అంటే ఇక్కడ ఎలక్ట్రాన్ ఫైండింగ్ ఎలక్ట్రాన్ మాక్సిమం ఉంది ఒక ప్లేస్ లో, నెక్స్ట్ స్లోగా 0 అవుతుంది. సో మళ్ళీ ఈ ప్లేస్ లో 0 అయిన తర్వాత మళ్ళీ ఆఫ్టర్ సమ్ గ్యాప్ ఎలక్ట్రాన్ ప్రాబబిలిటీ ఇంక్రీజ్ అవుతుంది. ఓకే, నెక్స్ట్ ఫర్ 3s. So in the discussion of s, there is no discussion about the other orbitals, other subshells. So 3s means so after 3s రావాలంటే 1s complete అవ్వాలి, 2s complete అవ్వాలి, then 3s is possible. 1s, 2s, see 3s. Okay, so here it is called maximum probability of finding the electrons. In the same way, we discuss about 2p orbitals. Okay, now see 2p. Next we see for 3p and 4p. Okay, so capital D in smaller. So 2p. So 2p, the p subshell starts from 2p only. So 1 low p possible level. So p discussion only about p discussion, not about s and d. Okay, so p low 2p, so it is 2p. So this is the place where the maximum probability of finding the electron is more. అంటే 2p లో తీసుకున్నప్పుడు maximum probability ఈ డిస్టెన్స్ దగ్గర maximum probability of electron ఉంటుంది. ఓకే, సో ఈ డిస్టెన్స్ మనం జనరల్గా బ్యాహెడ్ చేయాల్సిన అవసరం లేదు. సేమ్ ఫర్ 3p. For 3p starts after 2p, after completion of 2p only there is possibility of 3p. Here is the maximum probability distribution. Okay, next what is for 4p? Okay, when 4p takes place after completion of 2p and 3p only, there is a formation of 4p takes place. This is 2p, see 3p, this is for 4p. Okay, these are the maximum values. So here another important thing in these curves, so we need to observe generally orbitals or subshell size increases as the number of orbit increases for 1s. So 1s its size increases, 2s are nothing but as the size increases probability also increases. Okay, next in every graph there is some points except to these two graphs. So ఈ two graphs వదిలేస్తే, so ఇక్కడ ఈ graph లో there is a gap between two peaks. Here 3 peaks ఉన్నాయి అంటే ఇక్కడ 2 gaps are present. Here 1 gap is present, here 2 gaps are present. So what about these gaps? అంటే గ్యాప్స్ ఎలా ఉంది, మనకి లైన్ మనకు టోటల్గా ఎక్స్ యాక్సిస్ టచ్ అయిపోయింది అంటే హైట్ లేదు అక్కడ గ్రాఫ్లో. సో హైట్ లేదు అంటే there is no probability of finding the electron, అంటే ఆ ప్లేస్లో probability of the finding the electron 0. అంటే ఆ ప్లేస్లో ఎలక్ట్రాన్ ఫైండింగ్ అనేది 0 ఉంది. ఓకే, సో దే ఆర్ నోన్ యాజ్ ద పాయింట్స్ ఆర్ ద సర్ఫేసెస్ ఆర్ ద spherical surfaces. So these are known as, so here the symbolic is they are known as this is very important one. They known as spherical nodes. The other name for is radial nodes. Okay, radial nodes means where the probability of the finding the electron is 0 in these graphs. the spherical surfaces where the probability of finding the electron is 0. Height level is graph. So height level is the d value 0 only. So d value into the radial probability. And the probability of the finding electron లేదు అక్కడ అంటే electron finding చేసే 0 only. So that places are known as spherical nodes or radial nodes. Okay, now we define it. Okay, just remember these graphs. So based on these graphs we are going to write this spherical nodes formula. Okay, but here there is no spherical nodes are present. Two peaks మధ్యలో మనకు గ్యాప్ వస్తుంది. ఎనీ టూ పీక్స్ మధ్యలో వస్తుంది. ఇక్కడ ఉన్నదే వన్ పీక్. సో వన్ పీకే ఉంది కాబట్టి ఇక్కడ రేడియల్ నోడ్స్ అండ్ నథింగ్ బట్ స్పెరికల్ నోడ్స్ ఆర్ నాట్ పాసిబుల్. ఓకే, so now we define what are the spherical nodes. Okay, spherical nodes, they are also known as radial nodes. So what are the spherical nodes or not, but what are the radial nodes means? So these are the spherical surfaces. Spherical surfaces where the probability of spherical surfaces. Okay, where these are called spherical surfaces. The spherical surfaces where the probability of finding the electron is 0. They are known as spherical nodes or radial nodes. So what is the number of, we have a formula, the number of spherical nodes equals, for any of this type of plots, any of this type of graphs, so we have the formula to calculate it. So what is that formula is n minus l minus 1. Okay, so now we apply this formula. Already we written some arbitrary graphs. For example, one is how many gaps are there? 0. So apply this n, what is 1. So for s orbital it is s value, l value is 0. For s orbital l value 0 minus 1 means number of nodal planes 0. Already మనకు 1s లో ఓన్లీ 1 pk వచ్చింది కదా. సో అక్కడ గ్యాప్స్. ఫర్ ఎగ్జాంపుల్ 2s క్యాలిక్యులేట్ చేద్దాం. 2 minus 0 minus 1, that is we got only one surface, one node వచ్చింది అక్కడ. For example 3s, 3 minus 0 minus 1, that is 2. So here for 3s there is 2 radial nodes or 2 spherical nodes. Now for example we write it for 2p. Okay, take the total nodes perfectly. Okay, so మళ్ళీ తర్వాత మనకి స్కూల్ స్టార్ట్ అయిన తర్వాత ఈ క్లాసెస్ చెప్పిన there is no notes will be given for you and there is no detailed explanation for it. జస్ట్ ఒకసారి ఫాస్ట్గా రివైజ్ చేయడమో ఏదో ఒక స్టడీ అవర్లో చెప్పడం కానీ టోటల్గా చెప్పడం అనేది ఇట్ ఇస్ నాట్ పాసిబుల్. ఓకే, సో క్యాలిక్యులేట్ ఇట్ ఫర్ 2p now. For 2p, number of spherical nodes in 2p. What is the formula? N minus L minus 1. This is the formula. So N means here 2 value. What is the L value? What is the L value for P? 1. For 2p we know only one peak. There is no nodal nodes. 1. So what is 4p? That is 2. So for 4p there is a 2 radial nodes are present. Means this formula is perfectly applicable, perfectly useful to calculate the number of spherical nodes. Okay, even we calculate it for other orbitals. మనం ఇంకా వాటికి diagrams draw చేయలేదు, but we are able to calculate it. For example, 3D, 3 minus. What is the d value? What is the L value for d orbital? Nothing but d subshell. 0, 1, 2. N minus L minus 2. So there is a 3 minus 3, 0. For 4D, how much? 1. The same way for 5D, 5 minus 2 minus 1, there is 2 peaks are there. So what about 4F? 4 minus 3 minus 1, that is 0. So what about 5F? This is the last one. 5 minus N minus L minus 1, that is 5 minus 3 minus 1, we will get only 1. So all equivalent diagram draws a system. Now this is diagram for this. Okay. So what about for 3? So dx started only from third shell. So there is no spherical nodes. There is 0. Okay. Like see for 4D. The electron present in 4D and direct 4D and same. So 4D means 4D రాసామంటే దాని లోపల 3D కంప్లీట్ అయిన తర్వాత 4D వస్తుంది కదా. సో 3D 4D. So 1 radial node. Okay. That is 1 radial node. Okay. In the same way we can write it for 5D. So giving more example just to understand perfectly. 5D లో ఇంకా ముందు ఏంటి D 3D 4D 5D. So 3D 4D 5D. Okay, here how many peaks are, how many spherical nodes are there? 2 nodes. That is 2 nodes. Okay. Next we see for 4F. Okay, 4F. So F started ekkada manaki 4 tone start avudadi. F starts from just 4. It's only 1. 4F, 4 minus 3 minus 1, that you got 0. That is 5F. D value. Okay. So 5F starts after completion of 4F. Means here how many nodes are present? How many spherical nodes are present? 0 nodes are present. So means N minus L minus will perfectly works out for these calculating spherical nodes. Here important there is by seeing this type of curves, there are 2 questions are there. Just how to recognize what is the curve. Means this is for 4D which type of curve is possible. For 5D which type of curve is possible. Okay. So means curve ఇస్తే అది ఆర్బిటాల్ తో ఫైండ్ అవుట్ చేయాలి, లేకపోతే ఆర్బిటాల్ ఇస్తే దాని కర్వ్ ఫైండ్ అవుట్ చేయాలి. We see 1 or 2 questions for it. And here main some questions are there. Some questions are there based on this curves are. So main about the number of nodal planes. The number of radial nodes. For example, here now we are writing about number of peaks. Number of peaks in the graphs. Number of peaks. So simply we get the number of peaks with the help of N minus L. So for example, సో మనం దేనికి అప్లై చేద్దాం, we applied for 3D. So 3D కి అప్లై చేద్దాం. n value 3 minus what is the L value for D? 2 means only one peak. For example 4D కి అప్లై చేద్దాం. 4 minus D ఎంత 2 peaks. 5D 5 minus 2 that is 3. 3 peaks are present. Means the number of peaks is equal to n minus 1. For example, the number of peaks 2s కి అప్లై చేయండి. 2s means 2 minus that is 0. 2 peaks. For example, what about 3p? 3p కి అప్లై చేయండి. How many peaks? 3 minus for p value how much? L is 1, n minus L. Again 2 peaks. 3p లో మనం 2p 3p కి రాసేస్తాం. Means number of peaks is the formula. Number of radial nodes ki n minus L minus 1. We have some other concept. Means nothing but another formula we can say. Now we read the total main points. The number of, sorry, just wait. Again, there is one definition is there called, very important one, nodal plane, which is also known as angular node. Nodal plane or angular node. So a radial node ki angular node ki difference endante ikkada nodal plane or angular node tells about that one plane. అదే మనకి రేడియల్ నోడ్ లో ఏం డిస్కస్ చేసుకున్నాం, రేడియల్ నోడ్ లేదా స్పెరికల్ నోడ్ లో దట్ ఈస్ అ పాయింట్. ఒక స్పెరికల్ పాయింట్ దగ్గర ప్రాబబిలిటీ ఆఫ్ ది ఫైండింగ్ ఎలక్ట్రాన్ 0 ఉంటే దట్ ఈస్ కాల్డ్ రేడియల్ నోడ్ ఆర్ స్పెరికల్ నోడ్. సో ఇక్కడ ఇట్ టెల్స్ అబౌట్ ద not only the simple surface, not only this a point, it tells about the total plane. Okay, so what is the nodal plane means? The plane passing through the nucleus in which the probability of finding the electron is 0. So రెండిట్లో కామన్ ఏంటి మనకి, so radial nodes or angular nodes, in both what is the common? The probability of the finding electron is 0. But అక్కడ మనకు ఒక పాయింట్స్ డిస్కస్ చేస్తాం, ఇక్కడ మనం ప్లేన్ డిస్కస్ చేస్తాం. ఓకే, సో ఇది నార్మల్గా 3 డైమెన్షనల్ స్పేస్ మనం డైరెక్ట్గా చూపించలేం, అదేమో పాయింట్ కాబట్టి గ్రాఫ్లో డైరెక్ట్గా చూపిస్తాం. బట్ ఇట్ ఈస్ ద పాసింగ్ త్రూ ద న్యూక్లియస్. సో 3 డైమెన్షన్ మనం we can't show it directly. So what is the number of nodal planes means? So number of nodal planes, again there is a formula is there. It is equal to L. Means for S subshell it is 0. For P subshell it is 1. For D it is 2. For F it is equal to 3. So this is for orbitals. Means for example, for px equal 1, py is equal to 1, pz is equal to 1. Now for example 2p orbital calculate cheste 2p subshell ki what are the nodal planes annappudu 2p x ki 1 vastadi, 2p y ki 1 vastadi, 2p z ki 1 vastadi. Okay, just for 2p, just any general మనకి సబ్షెల్ అడిగాడు ఆర్బిటాల్ అడుగుతాడు. సో for p orbitals it is 1, for d orbital it is 2, for f orbital it is 3, for s orbital it is equal 0. ఓకే, సో ఇండివిజువల్ గా ఫర్ px py pz మనం సింపుల్ గా p ఆర్బిటాల్ రాసేస్తున్నాం. ఓకే, సో దట్ ఈస్ ఈక్వల్ టు l. Now we compare this formula with others. What is the number of radial nodes? N minus L minus 1. Now what is the total number of nodes? Total number of nodes means number of nodal planes, nothing but you can say angular nodes. Plus radial nodes. They are also known as what? Spherical nodes. Now just write a formula, that is this is L plus N minus L minus 1. So which will be cancelled here? This plus L minus L cancelled. So finally we will get N minus 1. Means the total number of nodes. Total number of nodes is equal to N minus 1. No, there is the last formula, that is number of peaks. Number of peaks in a curve or in a graph is equal to, already we discussed, that is how much? That was N minus L. Okay, so this is about radial probability distribution curves, and what are the nodal planes, radial nodes, angular nodes, number of peaks. Okay, now we need some problems, there's some questions based on this topic tomorrow. Okay.